Yes, guys, there are 3 digits after decimal now. So what you will do, you will make the number of digits even by adding 0 after 1 here. So it has become an even number of digits here. Ahmed and Arhan, so far everything's clear?
Yes, sir.
Okay.
Yes, sir, but why did we add one?
Why? No. I have taken just an example here. We have not added one. Okay. I just gave you an example. Suppose the number was like this, 7.291, in which after the decimal position, there are 3 digits. That is odd number of digits. So what we will do, we will make the number of digits after decimal even by adding 0. Okay.
Okay,
Now
sir.
let's get to let's get to the solution of the question. So we have taken this question here. Now place the bar over the digits and over the integral digit also. Now, so which number shall we take here? 2 square or 3 square? Which one is more appropriate here?
Sir, 2
4,
square.
2 square definitely, because 3 square will give you 9 and we cannot take a value greater than the divided. So we take 2 is square here, that gives you 4, right? So 4 here. Now, once you are done with the integral number, that is 7 here, the number before the decimal, once you are done with that, okay, quickly place a decimal after the quotient. After 2, place a decimal. All right, guys, we are done with the integral number, that is 7 here. Now, इसके बाद आपको same process apply करना है. After this, you guys have to follow the same process as we used to do in the long division method. The only difference here is that you need to put a decimal after you are done with integral number. All right, everything's clear so far?
Yes, sir.
Okay, Ahmed.
Yes, sir.
Okay, now bring down this number here, 29. Okay, and place a blank here. Now think of which number shall we take here, 42 or 43, which will be equal to 329. It's 84. It's how much? 129 here. What about 44? Or what about 45, guys? You guys tell me which number shall we take here? What about 47? That gives me 329, right? Okay.
Yes,
So we are
sir.
going to take 7 here. So 47 multiplied 7 gives me how much? 329. So that is the required number. 2.7 here is the square root of 7.29, right? It's 2.7 multiplied 2.7. That gives you how much? 2.7.
Excuse me,
Okay.
sir.
Yes.
After the first bar is solved, do we have to place the decimal point at the question, or
Just
and we have to remove
no, we
the
don't have
decimal
to.
point?
No need to remove the decimal point. Keep the decimal point here. Okay. Are you talking about here? Are we required to place a decimal
Yes,
point
sir.
here? No need to place a decimal point there. You need to place the decimal point here only. Okay, in the quotient only.
Okay, sir. So we have to remove the decimal point from 0.29.
Okay, look, what you guys need to do after you guys are done with this integral number, that is 7. Okay, just place a digit, just place a decimal after 2 here. Okay, don't get confused about this, whether we need to place a decimal here or not. We just need to place decimal in the quotient value. Okay, and also don't
Okay, sir.
focus on removing the decimal from anywhere. We just have to place a decimal in the quotient. Okay, just keep it simple. Okay, and in fact we can check it as well. Like if the number was 729, no, its square root is 27, right? Or here the number is 7.29. So the root is 2.7. So how do we multiply decimals? 2.7 multiplied 2.7, we get 729, and we are required to place the decimal from the end after 2 digits, right? So you can understand it like
Yes,
that
sir.
as well. Just treat the number as 729, and we know its square root is 27, and definitely since definitely the decimal is going to be in between 2 and 7. Okay, hope that's clear.
Yes, sir.
Okay. Now some basic questions for you guys. Okay. So there are a few questions. Okay. Quickly solve them. Like it should not take more than 2 or 3 minutes.
Oh.
First question is, which of the following is a square of an even number?
Sir, 6 to 5.
6 to 5. No. 6 to 5 is not a square of an even number. It's the square of 25. No. 25 square gives you 625. Okay.
So it can be 169 and 225 since they are the square of 13 and 15. So it's got to be 256.
It's got to be 256. Right. So 256 is the square of which number? Is it 14 or 15?
No, sir.
Look, 225 is the square of 15, right? 169 is
Yes,
the
sir.
square of 13. Okay. And then 13 square, 14 square is how much? 196 or 256?
796.
196 clearly. Okay. So what do we conclude from here? None of the above, right? In fact, 256 is not a square number at all. We can check that as well, right? So to the prime factorization of 256, so we are getting one odd pair. No, 2 here is not in pair, right? So 256 is not a perfect square number. So the answer is none of the above. Okay, yes, Ahmed. Are you having some network problem?
Yes, sir.
Okay, so we were discussing first question. Okay, the question says, which of the following is square of an even number? Okay, so option number 1, option number 2, and 4, these are square of odd numbers. While option number 3 is in fact not a square. It's not a perfect square. So the answer is none of the above. See question number, next question, see the next one.
Open out. 3, 4, 5, 5, 6,
So what do we have to do here?
Okay, these numbers here, you guys have to guess which one of them is odd one. Okay, look, do these numbers form Pythagorean triplets or not? Okay, that you have to check here,
Oh,
right? Pythagorean triplets are in this form, no? 2m, m square plus 1, and m square minus 1.
um,
Which one does not fit in the Pythagorean triplet format?
Sir, third option, 8, 15, and 17.
8, 15, and 17. Look, 8, 15, and 17 fits in the Pythagoras triplet. You see how?
So is it the
Num
second?
okay, we are coming to that. So 8, 15, and 17. Okay. So 8, you can represent it in the form of, if you equate it to 2m, since it's the smallest number out of the 3. So m you get here 4. Okay. And you put m in m square plus 1, the value of m here. So first number is 8, and in m square plus 1, that is 4 square plus 1, 16 plus 1, that you get 17. And then you have m square minus 1, that is 4 square minus 1, that means 16 minus 1, that is 15. So that fits in the Pythagoras triplet format. Hence, third one is correct. Okay, it's not it's not odd one. So third one is not the required answer here. See, first one, 3, 4, and 5. Okay, and see second one as well. Do they fit in this Pythagorean triplet format?
Sir, the first one I guess won't fit
Exactly.
since
Exactly. Because this 4 and 5, you see, 4 and 5, m square plus 1 and m square minus 1. Okay. So if the value of, had the value of m been 2, you could have fit in here. Okay. So you would have got what? 2 square minus 1, that will give you 3. And 2 square plus 1, that would have given you 5 here. So 3 you are getting, 5 you are getting. So what about 2m? That also is you are getting now. If the value of, if you are supposing the value of m was 2, so 2 multiplied 2, you are getting 4. So first one is also not odd one. Are you guys getting it?
Yes, sir.
First one is also not odd one.
Oh, okay.
Okay. What about second one? Let's check this one.
Yes.
5, 12, and 13. 5 is the smallest value, hence it's 2m. Then it's what? It's m square minus 1, and it's m square plus 1. Right, guys?
Yes, sir.
So find first
sir, the
find the
odd
value of
one
m.
is
Yes,
8, 15, and 16.
8, 15, and 16. Okay, let's check that one as well. Okay. So 2m, m square minus 1, m square plus 1. So here we get the value of m as 4. All right. And here, let's see if we get 15 or not. So 4 square minus 1, 16 minus 1 gives you 15 now. And 4 square plus 1, 16 plus 1, that gives you 17. And here in the question is given 16. Very good. Hence, question number 4 is the odd one out here. Right?
Yes, sir.
Okay. Okay. And see the third one also, 5, 12, and 13 here. So here the value of m is coming in fraction. You get 2.5. Okay. And 2.5 whole square minus 1. Will it give you 12? Check this one. Let's verify this one as well. Okay. So the third one is, sorry, second one, no? The second one is 5, 12, and 13. So 2m, then m square minus 1, and m square plus 1. So from here, you get m equals to 5 upon 2. All right, guys. So let's put the value in this one. So m we have taken it as 5 upon 2. So 5 upon 2 whole square minus 1. Find it out. Is it equal to 12 or not? And Ahmad, you find this one. Is m square plus 1, that is 5 upon 2, its whole square plus 1. Is it equal to 13 or not? Okay, find this one.
So Oh, okay, sir.
Yes, Arhan, what is the value here? Is it equal or not?
So
Alexis
it's
and Alexis.
29 by
It's how much? No, for this one. It's 25 minus 4 upon 4, right?
so it's 29 by 4, so it's not equal.
Which one? This one?
Yes, sir. No, sir.
This one?
Yes, sir.
It's 25. It's going to be 25 upon 4 minus 1. Okay, so that's why it is not equal, because it becomes 25 minus 4 upon 4. That is 21 upon 4 is clearly not equal to 12. Hence, we have got two answers here. Even option number 2 is the odd one here. Okay, now move on to next question. Is this question clear to you or not?
Yes.
Yes, sir. It is.
Okay, now move on to next question. What does the question says, Ahmed? Read the question.
If a number, oh wait, which of the following numbers cannot be the unit digits of the perfect
No,
square
C,
number?
C. Question number C.
Oh, see, if one member of a Pythagorean triplet is 2m, then the other two member are
Yes. What are the other two numbers?
So it's the second option. I mean,
Yes.
yes, sir. It's the second option.
Exactly. It's the second option. Okay. What does the next question say, Arhan?
Which of the following numbers cannot be the unit digit of a perfect square number?
Yes. So
Uh,
we know that for perfect square, unit digits can be 0, 1, 4, 5,
7.
6, and 9. Right, guys?
Yes, 7. Third.
7
So
is
it's
the
7.
answer. Exactly. Okay. Now, last question.
Mm,
If a
If a
number
number
ends in
ends
5 zeros. Mhm.
10.
5 zeros, then its square ends in dash zeros.
5. So is it 5?
Try to find it out now. Just take an example, find its square, and see if you see how many zeros you are getting.
So it ends in 6.
If a number ends in 5 zeros, then its square ends in how many zeros? Just take an example here. Take 2 and add 5 zeros. Okay. Find the square of this number.
Okay, sir.
It is pretty easy here. You will see just the number of zeros here are going to be 10 here. Right,
Yes, sir.
guys?
Yes, it is 10.
10. It is 10. Right? Just like how we multiply 100 and 100. Okay, we simply write 1 and then 4 zeros after it. So that is option number 4 is the right answer. Okay, so with this the chapter completes. Okay, in 5 minutes I'm going to give you a quick revision of what we have discussed so far in the chapter. Okay, so we talked about square number. You guys clearly know what is a square number. Okay, These are some square numbers. All right. So we know that a square number will always end with 0, 1, 4, 5, 6, or 9. It will not end with 2. It will not end with 3. A perfect square number. It will not end with 3. Neither it will end with 7. Okay. If a number ends with these 3 digits, clearly it's not a square number. Right. Okay. Or if the unit place is either 1 or 9, the square numbers unit digit will always end with 1. Then we have numbers like 4 and 6. In the unit place, if you have numbers as 4 or 6, it's always going to be 6 in the unit of its square. Right, guys? Okay. Then we have number which ends with 0. Okay, then its square will also have 0. But the number of zeros will be even or odd. Yeah. The number of zeros of their square will be even or odd. See, there are 2 zeros here, 2 zeros here, 4 zeros here, right? So number which has 0 in its unit place, its square will always have an even number of zeros at the end. Okay.
Okay.
Then we have triangular numbers like 1, 3, 6. If you add two triangular numbers, then what do we get? Suppose you add 3 and 6 here. 3 plus 6, you get 9. You add these two numbers, 6 plus 10, you get 16. You add these two, 1 plus 3, you get 4. Okay. So upon adding triangular numbers, we are getting a square number here, right? The square of 3. It's sorry, it's a square of 2. It's a square of 3. It's the square of 4. So that we also discussed. Okay. Numbers between square numbers. Okay. How do we find numbers between square numbers? We also discussed that one as well. Okay. For example, you have 25 and 36. We are required to find how many numbers exist in between them. So 25, okay, it's the square of 5 square. So we had the formula 2n. So n here is 5. So 2 multiplied 5, that is 10. So there exists 10 number between two continuous perfect squares. Remember, we always talk about consecutive, meaning एक के बाद दूसरा आने वाला square numbers, right? Like we have got 5 square and 6 square here. Okay.
Yes, sir.
Using this formula, you won't be able to find the how many numbers are there in between them. For example, if you have 5 square and 8 square, using this formula, you won't be able to find the numbers, right, Irhan?
Yes,
And
sir.
then we had another property, adding odd numbers. So uh, uh, when you add continuous odd numbers, you also get a square number. So if you, let's suppose you add 3 consecutive odd numbers, okay, you get 9, and it's the square of 3 consecutive odd numbers, right? Then any square number must be the sum of consecutive odd numbers starting from 1. Just this one, we are talking about this one. Okay, any square number, it's the sum of consecutive odd numbers that starts from 1. Right, guys? Okay.
Yes, sir.
And on any number you see, it's sum of consecutive natural numbers as well. Right. And how we need to find of which two numbers it's a sum of, like for example 25 here. Okay, if you are required to find it out of which two consecutive natural number it is the sum of. So 25, the two consecutive natural numbers can be find out using the formula n square minus 1 upon 2 and n square plus 1 upon 2. So the question is, what is n here? And simply is here the square root of 25, that is 5, right? So 5 square minus 1 upon 2 and 5 square plus 1 upon 2, that is 12 and 13. So 25 is the sum of 12 and 13. 12 plus 13, that gives you 25. Okay. Okay, then these were the exercise parts, and we observed some patterns in the numbers as well, right? Okay. All right, and Pythagorean triplets you guys already know. We just were solving questions on that. Okay. And from the square root, this you guys have any problem in this one?
No, sir.
Okay. So find me some square roots. Okay. Let's see if you guys remember that or not. 529. Okay. 121. 441. 484. Okay. Find the square roots of these numbers. It shouldn't take too much time.
Okay, sir. Sir, the second one is 11.
All right.
Uh, sir, the
Yes.
529 is 23 square.
23 square.
Yes,
Okay.
sir.
All right. Okay. Solve next one.
So third one is 20 square.
21.
21. 21.
Okay. What about fourth one?
Mm.
So the second one is for 20.
Second one is 11. Okay.
Sir, the last one is
22,
20.
sir. 22, sir.
22. That is 22. Very good. Okay. Okay, then I guess we have enough time left to start the new chapter. Okay. Are you guys comfortable if we start the new chapter today?
Yes, sir.
Okay.
Yes, sir.
So the chapter is basically completed, and you guys send the 6.4 was the final exercise, right? So Ahmed, you are required to solve the remaining questions. Okay. 6, 7, 8, and 9. Okay, and send them. Okay, so let's start the new chapter today. That
Excuse me,
is,
sir.
yes, Arhan?
Just confirming, but in my syllabus, in science, there is not a chapter named the one
Some
you
natural
taught
phenomena.
yesterday. Yes, sir.
Okay, okay. So you don't have that chapter in your syllabus. Okay. So Arhan,
Yes, sir, but I am not studying it.
okay.
I was just
Mm-hmm.
telling you.
Okay, okay. So Arhan, just do one thing, immediately after the class, send me the syllabus. Okay. I've got the syllabus of Ahmed, but your syllabus I haven't received. Okay. So immediately after the class, send me your syllabus. Okay. And
Okay,
today
sir.
your backup class was about to be scheduled, but it was not scheduled. Okay. So tomorrow, are you comfortable having backup class?
Actually, sir, I joined a coaching class,
Yeah.
which
Okay. Okay then. So
happens 2 hours in the evening.
okay. Okay.
So
Okay.
I I won't be able to join the
Okay.
class.
Okay. No issue. No issue. So from there you can complete your left out classes. Okay. So let's start the chapter. So you see, there's a story about one of India's great mathematician. It was S. Ramanujan. You guys must have heard of him. Okay. So there was one more famous mathematician, Professor G.H. Hardy, who came to visit him in a taxi, and the number of the taxi was 1729. So while talking to Ramanujam, Professor Hardy described this number. He said that this is a very dull number. Ramanujam quickly pointed out that 1729 was not a dull number but a very interesting number. How? He said that it is the smallest number which can be expressed as the as the sum of two cubes in two different ways. First, let me give you guys an introduction of what cube is. For example, if you have a number, let's say 1331, okay, so it can be written as 11 multiplied 11 multiplied 11, right? 11 multiplied 11 is equal to 121. 121, that was the square of 11. But if you further multiply it with 11 again, you get 1331. Okay, so 11, if you multiply it three times and you write a power of 3 over it, you get 1331. Okay, so we say that 1331 is the cube of 11 here, right? Okay, so what Ramanujam pointed out that 1729 is a very interesting number, and it can be expressed as sum of two other cubes. Okay, see here. He has written 1729 equals to 1728 plus 1. And interestingly, 1728 is the cube of 12 and 1 is the cube of 1 here. Okay, 1 can be simply written as 1 multiplied 1 multiplied 1. And this 1728, it can be written as 12 multiplied 3 times. Not only this, 1729 is sum of other two cube numbers also. So he got another pair of numbers 1000 and 729. So 1000, we know it can be written as 10 multiplied 3 times, right? And another number he took was 729, which is the basically cube of 3. That is 9 multiplied 9 multiplied 9, right? So 1729, later this number came to be known as Hardy-Ramanujam number, right guys? Okay, so
Yes, sir.
two important thing about this number 1729. It is interesting because it is the smallest number that can be expressed as the sum of two cubes, and in fact in two different ways, right? And since then it has been known as Hardy Ramanujam number. Okay, right guys. See, some of
Yes,
the
sir.
other numbers which can be represented in the similar manner are 4104. Okay, so it can be represented as the sum of 2 and 16, their cube. So 4104, it can be represented as sum of 2 cube plus 16 cube. Okay, let's check it out. So what is the cube of 2? It's 8. And what is the cube of 16? 16 multiplied 16 multiplied 16. You guys tell me. Yeah, how much is it? 256 multiplied 16. Yes,
Sir, it's 4090.
it's 4096. Right, so you get 4104. Okay, interestingly, there are other numbers as well, and in fact this 4104 can be represented as the sum of cube of 9 and 15 as well. Okay, so there must be infinitely so many numbers. Okay, but the smallest number was 1729. Okay, so that was history of the cube numbers. Okay, now let's come back to what are actually cubes here. Okay, so see, if a natural number m can be expressed as n cube, where n is also a natural number, then m is called the cube number of n. See here, I've taken a natural number n here. Okay, and I am writing, I am trying to express it in the form of n cube. For example, I have taken 512. So 512 can be represented as 8 cube. Meaning what? It means 8 multiplied 8 multiplied 8. Okay. So here we see that this n, that is 8, is also a natural number. It's a natural number,
Yes,
right,
sir.
guys? Okay. And m is also a natural number. That is 512. Okay. So this n, so this m will be called the cube of n here. This m will be called the cube number of n here. Okay. So that is basically about what are cube numbers and what are their cubes. Okay. Now, say this thing here. What is the cube's relation with cube numbers here? Okay. For example, see the first figure here. How many cubes are here? There's only one cube here. Okay. You all know what is cube. It is basically a 3D geometrical shape. Okay. Right. And what is the difference between a square and cube? Difference between square and cube. By the way, what is the difference between them? Yes, Arhan and Ahmed. If you see the face of a cube, it looks similar to a square. But what is the difference between the two? One is a 2D figure. Square is a 2D figure, right? Cube is a 3D figure. Okay.
Yes,
A
sir.
cube has got height, while a square does not have any height. Okay. And in a cube, we see all the edges, basically their sides are equal and are perpendicular to each other. You see this cube here. Okay. All these sides are making a 19 degree of 90 with each other, isn't it? All of them are forming 90-degree angle with each other. Okay, that is the property of cube in short. So see this one here. See this thing here. If one cube has all the equal sides of 1 centimeter, see, if this cube and this, all the sides are of 1 centimeter, then how many such cubes are needed to make a new cube of 2 centimeter? See here. Here I had only one cube. Now how many cubes do I need to make a new cube in which the side is of 2 centimeter? See here the next figure here. 1 centimeter and again 1 centimeter. So I am getting 2 centimeter here, isn't it?
Yes,
So
sir.
so how many cubes did I require to make such an arrangement? Or let's say if I were to make a new cube in which each side is of 3 centimeter. So what about this one? And this one, how many cubes do I require? Just
Sir,
yeah.
sir, 9.
In this one we get 9. If you guys try to find the number, count the number of cubes in this one, you will get it 8, and in this you have 1. Similarly, if we were to find out a cube in which the measurement of each side is 4 centimeter, then you guys will find it out to be how much? How much cubes do we require? You guys will require 64 cubes. So you see what we are basically doing here. We have got one cube here. Okay. And here we have placed 2 cubes in arrangement of 2 multiplied 2 multiplied 2. On each side, on each edge, you have placed 2 cubes, isn't it? See this one. 1 cube here, 1 cube here. And you have placed them together. See this side. 1 cube here, 1 cube here. And you have placed them together. Okay. And in this one, what about this one? The arrangement is like this: 3 into 3 into 3. On this side, on this side and on this side. You have placed 3 cubes, isn't it? 3 cubes in this side, right? 3 cubes in this side. I hope you guys can see where I'm marking. And 3 cubes in this side.
Excuse me, sir.
Yeah.
Is there no arrangement in cube 1?
It's just there's only one cube here, no? Okay. See, 1 multiplied 1 multiplied 1. It's simply one cube here. But to
Okay, sir.
obtain a cube in which the measurement of side is 2 centimeter, we have placed 2 cubes on each side. Okay, this is giving you length, breadth, and height. Okay, so on the height side, you have placed 2 cubes. Okay, and for the length and breadth also, you have placed 2 cubes on each side. Okay, and also length, breadth, and height, all of them are equal in a cube, right? Since the sides are equal,
Yes, sir.
right, guys? And same goes for another cube in which each side measures 3 centimeter. You have placed 3 cubes in the length, breadth, and height. So we get we can observe here that we have simply find the cube of the numbers. We are simply finding the cube of the numbers here. Okay, so that you can hear. Okay, so what if we need to make a cube of 3 centimeter with the cubes of 1 centimeter? We will simply cube the number. We will simply find its cube. So 3 cube equals to how much? 27, right? Or
Yes, sir.
what if we were to require to find side of 4 centimeter here? We will simply find the cube of the number. That will give you how much? 64. Right, guys?
Yes. Yes, sir.
Okay.
Yes, sir.
So, or what about 5? You would have gotten 125. So these are basically known as perfect cubes or cube numbers. 27, 64, 125. Okay.